There once was a fellow named Lewis who... What rhymes with Lewis?
Ruiz.
That's not a word.
Ruiz. Mr. Ruiz. No.
Yeah.
No. I don't think it works.
No.
Okay.
All right, let's just draw.
Hey, Lewis structures. These are Lewis structures of covalent bonds, folks.
Or covalent compounds.
Yeah, probably compounds. We drew these earlier when we talked about ionic bonds, and we draw electron dot structures, I think we called them. Those are actually Lewis structures as well, named after Mr. Lewis. And so we're going to be talking about Lewis structures here in our Bonding 5 lesson. Okay, bunch of words to copy down, and then we'll do lots of examples. There's several examples. Single bond, double bond, triple bond. Probably should pause the video and write these down. Okay, the key thing to understand with these bonds is that electrons are shared in pairs.
Right. One bond is one pair.
And a pair means
two
electrons. So when you see a bond, you might have seen this like, I don't know, out in the world. C, C, H, Cl. Each of these little bonds is actually two electrons. When you have a double bond, for example, oxygen has a double bond, these lines...
Each one is a pair. So
are
that's
four
electrons total.
And then there's such a thing as a triple bond. So, for example, in the substance cyanide, again, we'll probably draw this at some point maybe as an example, that represents 6 electrons. So they always work in pairs. There's, not never, very, very rarely do you have an odd number of electrons that are shared.
Nope.
It does happen in very rare circumstances. And typically, if you've got something with odd numbers of electrons, it's explosive. It doesn't like to stay that way. So we have some more definitions, and then we'll get to that kind of stuff. So again, you should pause the video and write down these two definitions. So the Lewis structure that we're learning about right here is the symbolic representation that shows the structure of a particular molecule.
Right. The valence electrons are indicated either as participating in a bond or as an unshared pair.
In an unshared pair are electrons that are not participating in a bond.
Right.
They're very important, and we'll see about that
very much so.
in a later podcast. Okay.
All right.
So now we're going to learn how to draw Lewis structures.
Okay.
Now to draw Lewis structures, there are 5 rules that you must apply.
Hey, guess what? Pause
This is
and
the
write
pause
these down.
video. Okay, so you've paused and written these down. So you're going to count the number, place 1 bond for each connection, distribute on the outside first, extra electrons on the central, redistribute for double or triple bonds. So you're going to have these rules. We're going to just do these together with several examples. So the first example is
H2O.
water. Now, for water, the first thing we've got to do is determine the number of valence electrons.
Right.
We've got 2 hydrogens and an oxygen. So if we go back and we look at this table of valence electrons, hydrogen right here has 1 valence electron.
Okay. And we have 2 of them.
So that'll be 2 because there's 1 plus 1.
Right.
Plus the value for oxygen. And oxygen's value, if you look over here, is 6. So, oops.
Wrong direction. Guess which one we're doing next?
6. So 2 and 6 is 8.
8.
So
Okay.
we have, think of it this way, ladies and gentlemen. You have 8 electrons to spin. It's like a count, if you will.
Right.
Now, you have to put 1 element in the center. Actually,
And hydrogen will never go in the center.
Yeah, hydrogen's on the outside.
Always.
So I'm going to put hydrogens on the outside. Now, notice I quickly went and I drew a bond. Now, again, what's a bond represent?
A pair of electrons.
2 electrons.
Right.
So of my 8, I have spent 4 electrons. So I have 4 more. Now, is the hydrogen happy?
It is. It only wants 2.
He only wants 2.
And
so
it has access to 2 with that. It's
with
that
a
bond
bond.
right
A
there.
bond counts as 2. So a hydrogen is happy. So I have 4 more to spend. So the rest of them go on the central atom, like the rules say. So I put 1, 2, 3, 4.
And we distribute them in pairs.
Yeah, always in pairs. Good call. Now, important thing. Now we ask, is oxygen happy?
Let's count.
2,
4,
4,
6, 8. It's happy.
It's happy. That's it. We're done.
All right.
All right,
That's
let's
easy.
do another one. How about NF3?
NF3.
Nitrogen trifluoride. Now, nitrogen is here and fluorine is here. So, Mr. Sam's 5.
Nitrogen has 5.
and
Fluorine has 7.
7.
Okay, so nitrogen
So-
has 5.
So I'm going to write that 5 here, and this will be 7.
7
but there's
times 3.
3 here, so that means times 3
So that's
So-
21 plus 5, 26.
is 26. Now, that's a lot more than 8.
That is.
Okay.
But-
now, the central atom is almost always, water is one of the exceptions,
Yeah.
actually. You always put the center
Or the first
atom.
element.
The first element is the center atom.
Or the one you have one of. Generally speaking.
That's a good call. So I've got 3 F's and an N.
Okay.
Now I've got to spin 26 electrons.
Okay, but we need a bond between the nitrogen and each
Yeah,
fluorine.
and usually they branch. I see sometimes where students will do N, F, 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 or something like that. Don't do that.
Just put the one that's by itself
He's
in the
the
middle.
middle dude. So you'll do not 2, 4, 6. Now, where do I go? Outside, inside?
Outside, inside.
I go outside,
Outside
first. So I
first.
spent 6, and this will be 8, 10, 12,
14, 16, 18, 20, 22, 24. Okay, all the outsides are done, but we have 26, so we have 2 more, and those go in the central
on
one.
the center.
28, or 26, I mean. There.
Yeah.
Okay.
Now, good news, guys. If you really can count, everyone's got 8. Look at this fluorine. 2, 4, 6, and the bond counts as 2 more 8.
Okay.
This nitrogen has 2, 4, 6, 8.
All
Those
right.
aren't double bonds; those are single ones.
Yeah.
Hey, by the way, these electrons are called what?
Unbonded pairs.
Unshared pair, I think. Yeah,
Yeah.
we're saying the same thing. And right here,
In older textbooks, you
this
might see them called a lone pair.
yeah, this is a bonded pair.
Right.
It's a lot of names, but the
Yeah.
bonded pairs are lines.
Right.
Unshared pairs are dots on the central atom.
Or on the outside atoms, too.
Yeah,
unshared.
but the ones you really care about are on the central atom.
Right,
That's true.
exactly.
Yeah, that's a good point. Okay, the next
All right,
example is
CCl4.
carbon tetrachloride.
Hey, it's raining outside.
Yeah, no, nice. We need moisture. Hey, carbon. Let's look at carbon on the periodic table. Carbon is element and column 4 here, and then chlorine is 7. So we had a 4 and a 7. So carbon gets 4,
All right.
and chlorine gets 7
And there's 4 of
times
them.
4. So
7 times 4 is 28.
28, and 4 is 32.
32.
So the central atom, and this would be carbon, so I'll apply 4 chlorines on the outside. So what's the first step? Or
Draw a
the next
bond
step?
between them all.
2, 4, 6, 8. Hey, by the way, carbon. He's happy already. He's got 8.
Carbon's good.
So if we can make chlorine happy, we're good to go, right?
Yep.
So
10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32.
32.
Okay,
We're good.
everybody's happy. Each chlorine has 8, carbon has 8, everyone's happy.
Sulfur dioxide.
All right, let's go.
All right, sulfur is right here in oxygen, and oxygen. Oh, hey,
Oh,
they're
they
right.
all have
So
6.
6 is the number.
Okay,
so
so
we've
sulfur has
got
6.
6 plus
6 times 2.
6 times 2.
So that's 18.
That's just 18. All right. So sulfur is in the middle. Oxygens are on the outside.
Okay, so we need a bond from the oxygens to the
2,
sulfur.
4.
Okay.
Now we go to the outside,
Yep.
right?
6,
6,
8,
8,
10.
10.
Okay.
He's happy there because he's
Yep.
got 8.
12.
12, right?
Yep.
14,
16.
And then an extra one's go on the
Central. So
central-
18.
All right, so our oxygens are, he's got 8.
Yep.
His oxygen has 8.
8.
And this
Sulfur has
sulfur has 6. Oh, bummer. I thought we could get 8, 8. Oh, it didn't work.
Nope. So what's our rule if one of them doesn't have enough? What do we have to do?
Hey, we haven't actually used rule number 5.
All right.
Redistribute electrons by making double or triple bonds if necessary to fulfill the octet rule.
I think this might be necessary.
This is necessary.
Yeah.
So, folks, the way to do this is you have to take a look at one of the oxygens. It doesn't really matter. It's a take these 2 electrons, instead of making them a unshared pair, we can erase them and put a double bond here.
All right. So we just took those 2 electrons, and those 2 electrons that were not bonded are now
Bonded.
the bond.
So sulfur dioxide has a double bond and a single bond.
Could I have taken 2 from the other oxygen instead?
Yeah, so it
And it
could
would have
also have
done
been
the same
written
thing?
simply like this, like that, with the appropriate number of electrons. It wouldn't matter which way you drew it.
Okay.
Okay.
Good enough.
The next one's an ion. 2 more examples, Mr. Sams. Nitrogen, N2. Nitrogen gas. You're breathing it all the time. Your body doesn't use it, but there's nitrogen. Hey, he's 5.
Okay.
And it's N2, so it's 5, 5. That's our 2
10.
times 5. We got 10. So we've got N
Bonded.
bonded to
to
N.
N. All right. So we start with the bond.
2,
2,
4,
4, 6,
6,
8,
8,
10.
10.
So the
Oh.
one on the right's happy, but the one on the left is not.
He's happy.
Yay.
But this nitrogen isn't happy. Well, again, when we run out of space, what do? We
Steal 2 and make it
steal
into
2.
a bond. So let's
these
take those 2.
and they're gone. They don't exist now. We've got a double bond.
Okay.
Now the guy on the left is 6.
Yeah.
It's not good.
Nope. So let's take 2 more.
Ah, hey, that's a triple bond.
All right, can you redraw that for me? So,
Yeah, so it's not so confusing. It's
Yeah.
N, triple bond N, and each of these would then have a pair of electrons, unshared pairs on either side.
All right.
So that's the answer for nitrogen.
Okay.
Let's
Good
do
enough.
one more, Mr. Sanders.
Alrighty.
It is a little bit complex.
Hey, look,
'cause
there's
it's-
a charge on there.
This one has a charge, and we haven't really learned too much about the names of these, or maybe we have. It depends on how order we do each year. But this negative charge indicates it has
An extra
an
electron.
extra electron.
So when we count the valence electrons, we have to include an extra
Have
one in
to
there.
add an
All right,
extra
so
one. So
let's
we
look
have
at
N and O.
nitrogen.
N is 5 and O is 6.
Okay.
So this will be
Five.
5 plus 3 times 6 plus
the 1. Okay.
This adds 1.
If that was a -2, we would get
2 more.
2 more.
And if it was positive 1, you would subtract,
Subtract
1.
one, right.
Yeah. So this is 18, 19, and 5, 24. So we got 24 to spend.
Okay, so nitrogen looks like it'll go in the middle.
Yeah, nitrogen's your
So
mildew.
it's by itself, and then
Got
oxygen's
3
around.
O's.
All right,
So
new
let's
bond.
spend 2, 4, 6,
Okay,
8, 10,
10,
12, 14, 16, 18, 20, 22, 24.
24. All the oxygens are happy, but,
But the nitrogen
is not. So
this,
just steal 2. Doesn't matter which 2. Psht. Everybody's happy.
everyone's happy. Now,
Now, one other thing is whenever you have an ion, put it in brackets.
because you need to indicate that this has an overall charge of -1.
So if it's an ion, put it in brackets and write the charge in the outside of the brackets,
Yeah.
indicating that the entire thing carries a charge of -1.
Which means 1 extra electron.
Yeah, that's it.
So that's how you draw Lewis structures for covalent compounds.
Yep, and you'll get lots.
Non-metal to non-metal. It's different from metal to non-metal. That's where you got to show arrows and
Right.
dots.
Yeah,
and
this
stuff.
you'll get lots of practice